simplify, of course, completely. Let's see where this goes. So over here we have x minus 3 minus 5x minus 6, 2 minus x being the denominator, minus 4 over x minus 2. So the first thing we'll notice here is that the denominators are almost exactly the same. However, we'll need to do the switch around trick over there. So I'm going to leave our x minus 3 alone, and then if I factorize the negative 1 over there, I have to multiply it with the negative on the outside. That becomes positive. And then I have 5x minus 6. Now I have x minus 2 minus 4 over x minus 2. Now you'd be tempted to do your LCD or LCM over here. However, these are already common denominators. So let's just see what happens if we were to simplify by just adding those. So we'd still have 5x minus 6 and minus 4 now become minus 10. So that was because we have a common denominator on both fractions. Now again, we could fall into the temptation, and in fact, let's just do it off to the side. Well, since this is over 1, if I were to place this on a common denominator, I'd have x minus 3 multiplied by x minus 2 over x minus 2, because that's my common denominator now, and then plus 5x minus 10. So let's see where that takes us. Okay, so I'm going to have x squared minus 2x, and then for the bottom part, I'm going to have minus 3x plus 6 plus 5x minus 10 all over x minus 2. So now I'm going to have minus 5x plus 5x, so that zeroes up, and this becomes plus 6 minus 10, so I get minus 4. So on top I'll have x squared minus 4 over x minus 2. I'm running out of space here, so I'll have x plus 2, x minus 2, because I can factorize the difference of squares, and then I have x minus 2. Those things cancel out, and my final answer is, so I'm gonna write right over there with the ugly arrow as x minus x plus 2. So that's my final answer for that. However, and this is not such a big however, the more practiced amongst us when it comes to factorization should be able to spot the following. Well, I can continue this as x minus 3 plus, you can take a common factor out over there, and that's just 5, and then I'll have x minus 2 over x minus 2. Anything divided by itself is 1, so we'll have x minus 3 plus 5, and minus 3 plus 5 is just plus 2, so I'll be left with the exact same x plus 2. However, it's a lot less work, and this is not laziness, it's being efficient. Practice brings that about. Well, let's go to our next example. Remember, we don't need egos. Your ego is not your amigo. Now we have an example involving some exponents. It's 4 to the power 2y minus 1 multiplied by 9 to the power y plus 1 all over 18 to the power y multiplied by 8 to the power y minus 1. Well, whenever we see total multiplication or fractions with exponents or variables in the exponent or letters in the exponents, remember the first thing is to go for primes. We want every number to be represented my prime numbers, no matter what the method. So 4 is just 2 squared, and I can write that a lot better. 4 becomes 2 squared. Remember, the exponent stays the same because I'm not changing the value of the number. I'm just rewriting it as a prime to the appropriate power. With that in mind, 9 becomes 3 squared. It's y plus 1. It's all over. 18 is 2 times 9, but that can be rewritten as 2 times 3 squared. So that's 2 times 3 squared, as we said, to the power y, and then 8 is just 2 cubed, all to the power y minus 1. So we need to simplify that slightly. Let's do it in a different color so it can stand out slightly. So over here we apply the power rule, so that's 2 to the power 4y minus 2. For this term we'll have 3 to the power 2y plus 2 all over 2 to the power y multiplied by 3 to the power 2y multiplied by 2 to the power 3y minus 3. Let's just generate a little space over here on the left hand side as we get ready to finish. So let's start with the smallest prime in a new color, which is blue. So we'll have 2 to the power 4y minus 2, taking care of that. Remember, when we divide the same bases, we subtract. For that, we'll open up a bracket, and that's the first y we'll subtract, and then there's that expression. Now, because we have a bracket, we can just add inside the bracket, so we'll have 3y minus 3. That takes care of all the 2's. And then let's move to the base 3. For that, we have 2y plus 2, and then at the bottom we have minus 2y. Note the use of the brackets to keep us safe from sign errors. So 3y plus 3y is 4y, and 4y minus 4y is just 0. Minus 2 minus minus 3 is 1, so we'll have 2 to the power 1. And here we have 2y minus 2y, that zeroes out, and 3 to the power 2 is just 9. Okay, which means we are left with 18 as our final answer. Let's do a clean up again. Maybe, just maybe, cleaning out this digital blackboard can become therapeutic. I don't know. We'll see what happens in future. Okay, let's get purple. Again, we have 2 to the power 2n plus 2 minus 2 to the power 2n minus 1, all divided by 4 to the power n plus 1. Well, remember, primes were applicable. Now, in our numerator, we don't have the problem with primes because 2 is prime and 2 is prime. However, we have more than one term, so our exponent laws don't apply exactly over there. At the bottom, we do have some work with primes. So let's do two little applications first. Now, our exponent laws, as we learn them, that is the direction of theory. When we multiply the same bases, we add the exponents. But that law can be undone, and think of that as the direction of application. What do I mean by that? Well, a to the power m plus n can be broken up in a to the power m multiplied by a to the power n, direction of application. This is the direction in which we learn the law. There we go. Applied. Then we do the exact same for the second term in the numerator, and that's 2 to the power minus 1 over there, all divided by, for 4 we have 2 squared, and then we have a n plus 1. Now, why would we do this? Quite simply, I have seen common factors. Imagine mixing concepts. What a wild idea. 2 squared is just 4. And then 2 to the power negative 1 I can rewrite as a half given my definition, and then at the bottom I'll end up with 2 to the power 2n, and then I can split off that 1 with a 2. That allows me to cancel those terms. This becomes at 7 over 2 divided by 2, which is just equal to 7 over 4. Somebody please check my math and make sure I'm right. Yes, I am. That's good. I'm happy. Go have fun and prep for tests.